Welcome to this tutorial on Gradio and Hugging Face Spaces, which offer excellent ways to run and share machine learning applications. Hugging Face Spaces provides a flexible, controlled, and secure environment for hosting various applications. While it supports multiple options like Docker containers and Jupyter notebooks, today we'll focus specifically on Gradio applications. One of the most appealing features of Hugging Face Spaces is its support for powerful hardware accelerators. You can use NVIDIA GPUs or Google Cloud TPUs for high-powered machine learning applications. The platform handles all the hardware management for you at reasonable hourly rates. To get started, you'll need to visit the Hugging Face homepage and log in. Once logged in, navigate to Spaces, where you can create a new space. Although Streamlit is another popular option on the platform, we'll be working with Gradio today. After clicking on Gradio, you'll see several templates to help you begin. Let's select the text-to-image template and use the free space environment. The free CPU basic hardware tier allows you to create unlimited spaces, but remember that if you need more powerful GPUs or Google Cloud TPUs, you'll need to pay an hourly fee. We'll proceed with the free option and make our space public. When you create the space, it automatically builds and deploys your application in a container. One of the great advantages here is that you don't need to manage Docker environments or write Docker files yourself. Instead, you can focus entirely on writing Python code for your Gradio application. We'll first explore how to use the application, then examine the files that make it work, and finally, create our own application from scratch. The text-to-image demonstration is particularly interesting, though you should note that since it's running on a basic CPU and RAM instance, image generation might take several minutes to complete. A notable feature of these applications is their accessibility. Even users who aren't logged into Hugging Face can use your application, making it truly public and accessible to everyone. Let's examine the key files that make up a Gradio space. If you're familiar with Python, you'll recognize the standard structure. There are three main files to understand. First, we have the requirements.txt file, which lists all the Python dependencies needed for the space. Second, there's a readme.md file that contains metadata about the space, such as its name and branding information. Finally, there's the app.py file, which contains the actual application code. In the app.py file, you'll find several AI libraries being used, but Gradio itself is the core library for creating the user interface. The application will automatically try to use a GPU if one is available. In our example, we're using the Stable Diffusion XL model for image generation. While there is some AI-specific code, the most important parts are within the Gradio blocks, where we define our application structure. These Gradio blocks let you define your application's elements in a straightforward way. You can include various components like markdown text for headings and instructions, text input fields for user prompts, and image displays for results. The template we're using also includes advanced settings with features like sliders and additional text fields for fine-tuning the image generation. At the bottom of the file, you'll find gr.run, which connects all the pieces together, linking your inputs, outputs, and triggers before launching the Gradio application. It's impressive that with just about 150 lines of Python code, we can create a fully functional text-to-image application that's accessible to anyone on the internet. For managing your space, Hugging Face provides a complete set of Git-based version control tools. This uses Git quite directly, which is why when you look at the Files section, you'll see a layout focused on commits and version control. To work with your code, you can click the Clone Repository button to get the Git commands needed for downloading and updating your project. You'll need an IDE or integrated development environment to write your Python code. While you can use any IDE you prefer, in this tutorial, we'll use Google Cloud's Cloud Shell Editor. When working with the code, you'll use the terminal in your IDE to run Git commands. Since we're working with relatively small files, we won't need Git large file storage. Now let's create our own simpler application to better understand the core concepts. Instead of making an advanced AI application, we'll create a basic text analysis tool using the TextBlob library and possibly NumPy. One nice feature of Hugging Face spaces is that Gradio is automatically installed by default, so we don't need to include it in our requirements. We'll start by creating a simple Python function that analyzes text. At this stage, it's just a regular Python function without any Gradio components. To transform this into a web application, we'll use a block which serves as a wrapper for our entire Gradio application. This allows us to add various elements to our interface. We can start by adding a title using Markdown, followed by user instructions. Gradio provides a row component that helps us organize our interface by creating new blocks within the web app. We'll use this to add a text box where users can input their text for analysis. All of these Gradio elements are well documented on the Gradio website. In the documentation, you can find detailed information about layout options like block and row, as well as various components like text boxes. Each component comes with its own set of customizable options. Think of these components as tools in your toolbox for building your Gradio application. For cases where you need more flexibility, Gradio provides an HTML component. This component is particularly useful because it allows you to insert any custom HTML content into your application. After setting up our input elements, we'll add more rows to our application, including a submit button and spaces for displaying our results. The final piece of the puzzle is the .click functionality, which defines what happens when someone clicks the submit button. When setting this up, you need to specify your inputs, in our case the text from the input box, and outputs, the various analysis results we want to display. The input names must exactly match the components you defined earlier. Finally, we use demo.launch to combine all these elements and start our application. After creating our application, we need to deploy it to Hugging Face spaces. When checking our Git status, we'll see significant changes since we've removed the original text-to-image code and replaced it with our new text analysis application. We've also modified the requirements file, removing the previous AI-related dependencies and adding just TextBlob and NumPy. When committing these changes, it's recommended to use the Hugging Face no reply email format to maintain privacy. To set this up, we use git config commands to set our demo name and email. Our repository is already configured to point to our Hugging Face space as a remote Git repository, which means we can push our changes directly to it. However, you might encounter an issue with username and password authentication. If this happens, there's a simple solution: using an access token instead. To get one, go to the Access Token section on the Hugging Face website and create a right token. After copying the token, you'll need to modify your Git remote URL to include these credentials. This involves adding your username and token to the repository URL. Once you've properly configured the credentials in your remote specification, you should be able to push your changes successfully. When you do, your space on Hugging Face will automatically start rebuilding. You can monitor this process by visiting your profile and navigating to your demonstration space. As an alternative to using tokens, you can also set up SSH keys for authentication. After the initial deployment, we discover an error in our application. The logs showed that while we were correctly calculating various metrics like sentiment score, word count, character count, and average word length, we need to modify how we're unpacking this data in our application code. This is a common part of the deployment process, identifying and fixing issues as they arise. The fix requires another round of committing and pushing our code, which triggers another automatic rebuild of our application. During this process, it's helpful to monitor both the build logs and container logs to catch any potential issues. After our fixes, the application starts working properly, displaying all our text analysis outputs in a clean, organized format. This workflow demonstrates one of the greatest advantages of Hugging Face spaces, the continuous integration process. Every time you push changes to your repository, your application automatically rebuilds and deploys, making the development process smooth and efficient. Let's consider some key points about what we've accomplished. With relatively simple Python code, we've created a web application that anyone can access and use. The process demonstrates how Hugging Face spaces makes deployment remarkably straightforward. You don't need to worry about server configuration, Docker containerization, or complex deployment procedures. Everything is handled automatically once you push your changes to the repository. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include all the code and diagram files in the description as well. Thank you very much for watching to the end, and please enjoy responsibly.